So far in our chapter about rational expressions and equations, we have looked at how to simplify rational expressions. We've learned how to multiply and divide rational expressions, and we even learned how to add and subtract rational expressions. And today we're continuing with our rational chapter by looking at what rational functions are. So we're using all of our information that we've learned about how to manipulate those expressions, and now we're actually looking at the functions. So let's go ahead and just look at what a rational function looks like, or what it's defined as. So a rational function, so it's a function, so it's going to say f of x or y, okay? And it's going to be equal, and it's going to look like this in general. P of x over q of x, okay? So that P of x and Q of x, those are going to be polynomial functions. So P of x and Q of x are just functions. They're just two more functions, and they're polynomial functions. So anytime you see a function over a function, you have what's called a rational function. And so one very important thing, Q of x, the function that's on the bottom, can never ever equal 0 because we can't divide by 0. So let's begin on how do we evaluate a rational function. Well, it's just going to be like how we evaluate any function. We substitute the value of the variable and simplify. Okay? So how do we evaluate? We substitute the variable, the value of the variable, and simplify. Okay, so for example, let's look at example 1. If I have f of x equals x minus 3 over x squared plus 4x plus 3. So first of all, this is an example of a rational function. So we have a function on top, x minus 3. That would be like P of x. And then we have a function on bottom, x squared plus 4x plus 3. That would be like our Q of x. Okay? And so what we're going to do with this example, what they're wanting us to do, they want us to find f of 0, f of 3, f of negative 1, f of negative 2, and f of negative 4. So we have to find all of these numbers, right? So we're going to get a number for an answer, because what we have to do, so instead of saying f of x, we have f of 0. Instead of saying x, we have a 0 there, right? Instead of saying f of x, we have f of 0. That means x is 0. That means anytime we see an x, we're going to replace it with a 0. So to find f of 0, we're going to replace x minus 3 with 0 minus 3. And then x squared with 0 squared plus 4 times 0 plus 3. Well, 0 minus 3 is negative 3. And then on the bottom we get 0 plus 0 plus 3. So we have negative 3 over 3, which just becomes negative 1. Alright, so now let's find f of 3. So instead of saying f of x, we're saying f of 3, which means anytime we see an x, we're going to replace or substitute that x with the 3. So we have 3 minus 3 over 3 squared plus 4 times 3 plus 3. So 3 minus 3 is 0. 3 squared is 9 plus 12 plus 3, we end up with 24. And 0 over 24 is just 0. All right, so next number, f of negative 1. So we have negative 1 minus 3 over negative 1 squared. Notice my use of parentheses, right? I'm not going to do with negative 1 squared without parentheses because then I'll get negative 1, which isn't true. Negative 1 squared is positive 1, but you have to make sure you're using your parentheses. And then 4 times negative 1 plus 3. So negative 1 minus 3 is negative 4. And then we have 1 minus 4 plus 3. So that means we get negative 1. I'm sorry. We get 0, right? Because that's 1. And then negative 3 plus 3, that ends up being 0. So we have negative 4 over 0. Well, first of all, that doesn't exist. You can't divide by 0. So we would say this is undefined. That would be our answer, undefined. All right, so next one we're going to do f of negative 2. So we have negative 2 minus 3 over negative 2 squared. Notice my use of parentheses. Plus 4 times negative 2 plus 3. So negative 2 minus 3 is negative 5. And then we have negative 2 squared was 4. This is plus negative 8, so that's negative 4. And then we have plus 3, so that gives us negative 1. So we have negative 5 over negative 1, which ends up being positive 5. All right, so now we're going to do the last one, f of negative 4. So that means we have negative 4 minus 3 over negative 4 squared plus 4 times negative 4 plus 3. So negative 4 minus 3 is negative 7. And then we have negative 4 squared, that's 16, minus 16, then plus 3. So we end up with just 3. So we get negative 7 over 3 for the answer for f of negative 4. All right, and that's how we evaluate rational functions. And it's very important that we know how to evaluate rational functions so that way we can graph rational functions. So what I want to show you right now is how to do all of this on your calculator. So the first thing you would do is you would go to y equals, and so you want to plug in our function, which is x minus 3 over x squared plus 4x plus 3. So I know that I make a really big deal about indicating my groupings, and the reason I do that is because also it's helpful whenever you have to enter that into your calculator. You want to make sure you're using those parentheses. So I'm going to use x. Here's my variable button here, x. And then I have minus 3. Okay, and then the fraction line can be indicated with division. Then I have x squared. So you have a squared, oh, I forgot my parentheses. Here we go. So here's x. We have our square button right there. So squared. And then plus 4x plus 3. So I have this entered in. So what I want to do is I want to be able to see what my answers are if I plug in values of x. So what we're going to do is we're going to take a look at our table. So if you hit second table, you'll see that you can plug numbers in. So if you already have numbers in there and it's not letting you enter numbers, so for example, I can hit the number 0, press enter, and it's going to tell me what 0 is. If your calculator doesn't do that, you can change that. If you will go to second and then window where it says table set, so you have to hit second first, and then where it says independent, so independent is the independent variable, your x. So if you change it from auto to ask, that means that you get to ask the calculator, what is my answer if I have x for this? So change it to ask, and then go back to your table by hitting second graph. That will give you to your table, and now you can plug in your own x values to evaluate for y. So we plugged in 0, and we got -1. Now let's do 3, and we get 0, which is correct. Let's do -1. So notice that when we do -1, it gives us an error. That's because it's undefined. Then we'll do -2, and then we get 5, which is what we got here. And then we have to do -4, which is -2.333, which is the same as -7/3. All right, so now what I would like to do is look at how we can graph these rational functions. So we're going to begin with graphing the parent function of rational functions. So this is your basic rational functions with no transformations, no shifts on it, just your plain basic rational function. We call it the parent function. We're going to graph f of x is equal to 1/x, okay? So the first thing we want to do to graph a function is we find our ordered pairs, right? That's our first step, is find our ordered pairs. So we set up a table. We're going to do x and then figure out what f of x is. So if make sure that you do a lot of numbers and make sure that you are picking positive and negative numbers, so that way you can make sure you know what the graph looks like. Because if you only do a couple of numbers and they're only positive, you're not going to know what the graph looks like on the entire graph, right? So we'll start with -3. So if I were to plug in -3 for x, I would get -1/3. Okay, let's see, if I do -2, I would get -1/2. If I did -1, I would get -1. If I were to do 0, can't divide by 0, so that would be undefined. Okay, and then let's see if I do 1, I'd get 1. Let's see if I do +2, I would get +1/2. If I were to do 3, I would get +1/3. All right, so there's a nice table there. All right, so let's plot these ordered pairs that we found. Okay, so here's my nice graph. Okay, so when we had -3, we had -1/3. So we'll go to -3, -1/3, probably right around there. And then -2 got us -1/2. And then -1 got us -1. Okay, so here's what our graph looks like so far. Notice that it's kind of curved, right? Let's see. 0 was undefined, and then 1 went to 1, right? Okay, and then 2 was at 1/2, and 3 was at 1/3. So again, it's almost a mirror of this. They're curved, and they're almost reflected from each other, right? Okay, so 0 is undefined. So what we want to do now is we actually want to substitute fractions and evaluate for some fractions to find out what happens between -1 and 0 and 0 to 1. So we know that if we get 0, it's undefined, but we could plug in 1/2 and we could still have an answer. We could plug in -1/2 and still get an answer. So what we want to do is we want to know what happens as you get closer to 0. So we're going to plug in some fractions. Okay, so let's start with 3/4. So if we plug into 3/4, we have 1/3/4, which is the same as 4/3. Okay, so if we plug in 1/2, 1/1/2 is the same as 2. and then 1/4 becomes 4. So if I were to plot those, let's see, 3/4 went to 4/3. So that's 1 1/3. It's all the way up here. Okay, and then 1/2 went to 2. And then 1/4 went all the way up to 4. So notice that our graph kind of grows. And it looks like it's approaching that y-axis, but it's never going to touch the y-axis. Okay? Let's plug in some negative fractions. So if we plug in -3/4, we just get -4/3. If we plug in -1/2, we get -2. Okay? If we plug in -1/4, we get -4. So again, it's going to be growing. Okay? So if we do -3/4, that's -4/3. If we do -1/2, that's -2. If we do -1/4, we get -4. So notice that our graph goes this way. So you can see the nice symmetry going on. All right, so to finish graphing, all we have to do is connect the curves, right? So we know that it's kind of doing this. And we notice that it's never going to hit that y-axis. So we're going to do this to indicate that it's going to keep going but never cross the axis. There we go. All right, so in our calculator, we can see what that looks like as well. Okay, if you go to y equals and you plug in our function, which was 1 divided by x, and we take a look at our graph. Oh, my setting's a little off, so I'm going to go ahead and fix my window. Or actually, I'm going to go to zoom and fix my zoom. So I'm just going to go to number 6, which is the standard, and that puts it back into the frame. So as you can see, here's my graph, and then this is what I have graphed here. Okay. So there's a faster way to graph rational functions other than plotting all these points. There's even a faster way than plugging into the calculator and trying to figure out what that graph looks like because it's so small. You had to be able to recognize some patterns of rational functions. So in our example, you noticed that we got closer and closer to both axes, but we never crossed these axes. So when a graph is approaching a line this way, we call that an asymptote. So we can have a vertical asymptote or a horizontal asymptote. So when we were approaching the y-axis, but not touching the y-axis, we call that a vertical asymptote. And you usually indicate it with a dotted line that has arrows on it. That's what we usually call a vertical asymptote. And then notice how we were approaching the x-axis, but never crossing it. So we were approaching a horizontal asymptote. So we can do a dotted line there as well. And that will indicate our horizontal asymptote. Okay, so asymptotes provide a guide for graphing, because if you know where your asymptotes are, you know how to sketch your graph after the points that you have plotted. Okay, so as you substitute larger numbers into the denominator, your resulting fractions approach 0. Okay, and so since your y values are approaching 0, that means that the x-axis is an asymptote. Okay, so for this reason, the x-axis is always a horizontal asymptote when the denominator has a higher degree than the numerator. Okay, so let's write that down. It's a very important fact. Okay, so your x-axis, y equals 0, is always a horizontal asymptote if, big if here, okay, if the degree of your denominator is bigger than the degree of your numerator. So the degree of your denominator is bigger than the degree of the numerator. Okay, so for example, the degree of our denominator was 1, and the degree of our numerator was 0, right? So that means that we have y equals 0, or the x-axis, as a horizontal asymptote. Okay? And then vertical asymptotes occur when the function is undefined. So remember, for it to be undefined, that means the denominator is equal to 0. So to find out where our vertical asymptotes are, all we have to do is find when is the denominator equal to 0, okay? So to find vertical asymptotes, we want to find where your denominator is equal to 0. And that's how you find your vertical asymptotes. All right, so let's look at an example of graphing a rational function using these characteristics, okay? So we're going to graph f of x equals 1 over x squared plus 3x. Okay, so first we want to find our vertical asymptotes. So we're going to take our denominator and we're going to say, okay, where does our denominator equal to 0? Because that's where our vertical asymptotes are. So we do x squared plus 3x equals 0. And we're just trying to find when is x, if we were to solve for x, right? So first thing I do is factor out the x. So now I have x plus 3 equals 0. And so now that we have a product that's equal to 0, we can use the 0 property rule. So that means either x equals 0 or x plus 3 equals 0. So that means either x equals 0 or x equals negative 3. And so these are the two equations of our vertical asymptotes. Remember, vertical lines are in the form of x equals a number. So x equals 0 and x equals negative 3, those are actually vertical lines, right? But we're going to draw vertical asymptotes. So at x equals 0, there's a vertical asymptote, and at x equals negative 3, there's a vertical asymptote. So here, let's put one at 0, and then let's put one at negative 3. So now we have our vertical asymptotes, okay? And then notice that our degree of our denominator is larger than the degree of our numerator, which means that we also have a horizontal asymptote at y equals 0, or the x-axis. So now we have all of our asymptotes drawn into our graph, which is awesome because now we can pick some values and we kind of know like how to pick our values. Like, I want to pick just a couple values over here, a couple of values in between here, and a couple values over here. And now I'm not randomly guessing, now what numbers I should plug in. Like, I know like kind of what values I want to see so I can see where my graph is, okay? So we're going to start with x equals 1. So again, we're getting some points. We're going to do x and f of x. So if I plug in x equals 1, that's 1 over 1 squared plus 3 times 1. So that becomes 1 over 4, right? So when x equals 1, y equals 1/4. So it's all the way down here. Okay? And then let's plug in a negative 1. And that means I'm just going to get negative 1 squared is 1. And then minus 3, right? And that's going to give me 1 minus 3, yeah, that's negative 2. So I have 1 over negative 2, or negative 1/2. So when I plugged in negative 1, I got negative 1/2. And then we're going to plug in negative 4. So when I plug in negative 4, so that's 16 minus 12, which is 4. So I get 1/4. So when negative 4 went to 1/4, that's up here. And then let's just do one more in this area. Let's do negative 2. So when I do negative 2, that's 4 minus 6, that's negative 2, so that's negative 1/2. So at negative 2, I got negative 1/2. All right, so from here we can sketch the graph by approaching each of the asymptotes without crossing the asymptotes. So what that means is that if I have a point here, I know that it's going to go this way. Oh, but there's an asymptote, which means that I have to start going up and go that way. And then I know that I'm going to go this way, but I'm never going to cross this asymptote right here, which means it's just going to continue on in this direction forever. So now I have this part of my graph. And then over here, I know it's never going to cross the x-axis, and I know it's never going to cross either of these. So when I sketch this, I'm going to go, here we go, oh, can't go past that asymptote, so I'm going to go downwards. And then in this direction, oh, can't go past the asymptote, so now I'm going to go this direction. And then for up here, I know I have a point, and I know that point can't cross this horizontal asymptote, so it's just going to go in that direction. And then the same thing going up, it's going to go in that direction. All right, and that's how you sketch the graph. Okay, and then you can verify it, of course, with your calculator, making sure that we use parentheses. So we have 1 divided by parentheses. We're going to do x squared plus 3x. Hit our graph. So, and then as you can see, so here, this piece right here is this piece, okay? And then you have this little upside down U right there, that's this piece. And then you can barely see the right hand side of the graph, which is why it's important to know how to do this, right? And so what I would do is I would identify my asymptotes, and then actually I would do this piece right here. I would use my calculator for that. I would just go to my table and get the points and then graph the points there, and then using my asymptotes sketch the graph. Because if you notice the graph on your calculator, it doesn't show up very much, so you're not going to actually get all of the graph if you're just using this. You have to be able to identify your asymptotes and then use your points, which you can get from your table, to sketch where that graph is. All right, so another thing that's useful, let's say you do not have a horizontal asymptote, then what you can do is you can find your intercepts, okay? So find any x-intercepts, and those can help you figure out when you're crossing the x-axis, and that can help you sketch your graph as well. So let's do one more example where we don't have a horizontal asymptote and we have to use our intercepts to see what the graph actually looks like. So we're doing example 4. So we're going to graph f of x equals x squared minus 4 over x cubed minus 1. Okay, so the first thing we want to do is we want to find our intercepts, right? So to find our intercepts, first of all, the reason we're finding our intercepts is because we know we don't have a horizontal asymptote. So because we don't have a horizontal asymptote, we want to find our y-intercepts. So to find a y-intercept, you let x be 0. Okay, so we're finding our y-intercepts by letting x be 0, right? So that means that we have 0 squared minus 4 over 0 cubed minus 1, which means we have negative 4 over negative 1, which is positive 4. So that's our y-intercept, okay? So that's where it's going to go through the y-axis, okay? And then we can find our x-intercept by setting the numerator equal to 0, okay? So finding the x-intercept, okay, we want to let y equal 0 only for our numerator. Okay, so our numerator is x squared minus 4, so we're letting y equal 0, so 0 equals x squared minus 4, okay, which means that we add 4 to both sides, so x squared equals 4, which means x equals plus or minus the square root of 4, which is plus or minus the plus or minus 2, right? Okay, so now we have our intercepts, okay? Then we can find our vertical asymptotes by setting our denominator equal to 0. So we set our denominator equal to 0. So x cubed minus 1 equals 0, okay? So when we do that, let's see, solving for x, so 1 equals x cubed. So what number cubed equals 1? Well, 1, right? So that means that we have x equals 1 as a vertical asymptote. So if we were to draw our graph, okay, we know we would have a y-intercept at 4. So 1, 2, 3, 4. We know we have a point there. Okay, and then we know we have an x-intercepts at plus and minus 2. So we know that the graph is going to go through those points, okay? And then we have a vertical asymptote at x equals 1. Okay, so this is going to help shape our graph, right? So we can plot some points, right? So here's what I would do. I would go to my calculator, plug in the numerator, x squared minus 4 over, so for the x cubed, you actually have to use the caret, so I'm going to put in another set of parentheses, so x cubed, okay, and then minus 1, and then close the bottom parentheses. So I'm going to go to my table, and we can just get some points. Let's see, I want to get some points over here, so let's do, this was 1, right? So let's do like 1/2. So 1/2 goes to 4.287. So 1/2 is all the way up here, right? It's past the 4. All right, so now I know that that graph is going to go that direction. So let's do between 1 and 2, let's do 1.5. And that is negative 0.73. So I know that 1.5 is down here, which means that this graph is going to go this direction. Okay, and then let's do 3. So 3 goes to 0.19, so that means it's somewhere over here. Okay, which is good because now I know that my graph is going to go like this. Okay, and then we know that this happens here. It's going to go this direction. But what about between -2 and 0? Let's do 1. Or I'm sorry, -1. Now -1 goes to 1.5. So that's right here. Okay. So that's good. So we know we're going to go this direction and then that direction. Okay. So let's do -3, which goes to -1.7. So right here. So now we kind of know what our graph looks like. So we know this goes like this. And then we know we have, you know what, let's do -4 to see what's going to happen. -4 is right here. So notice how that's really close to this one. So instead of going down, I know it's going to go like that. So we have this type of graph. Okay? And then we can check it by looking at our graph on our calculator and seeing if it's similar. So here's this piece here, and then notice how this kind of goes, and that's kind of like what we have here, right? It's kind of, it goes to the x-axis and then goes upwards. Or it goes to the y-axis and goes upwards. All right, go ahead and try some problems on your own.